With that being said, I'd like to have our first morning speakers join us. And as I introduce you, speakers, if you could turn on your cameras so that we can see you. First up, Mr. George Berghorn is an assistant professor of construction management in the School of Planning, Design, Construction at Michigan State University and an adjunct assistant professor in the MSU Department of Forestry. George earned a PhD in construction management from MSU and a Master of Environmental Studies degree from Yale University. He is a LEED accredited professional in building design and construction and a certified green professional from NAHB. Sorry about that. Next up, if we could have Mr. John LeFevre. John is the Director of Planning, Design, and Construction at Michigan State University. He has been involved with higher education, infrastructure, and building projects his entire career. He holds a bachelor's and master's degree in civil engineering from Michigan State. He has worked in the private sector for an architect and engineering firm for 22 years before joining MSU in 2011. He has been responsible for the delivery of over $160 million per year in construction volume at MSU for the last 9 years. And last but not least, Dr. Mark Rudnicki is currently a professor of practice in forest biomaterials in the College of Forest Resources and Environmental Science at Michigan Tech University. Go Michigan Tech. Mark is an advisory board member for the 2021 World Bioeconomy Forum and a founding member of the Houghton-based FinZone, a commercial launchpad for Finnish tech companies entering the USA. His diverse research interests include tree biomechanics, forest meteorology, circular bioeconomy, biomaterials, and of course, mass timber. Gentlemen, thank you for joining us. For those of you that are on now, if we could have everyone but George, please shut your camera off. And George, we are going to turn it over to you for our first session.
Great, thanks, Brenda. Okay, so this morning I'm going to talk to you a little bit about some cost and benefit work that we've done here at MSU on mass timber, and it's really wrapped up around four themes: construction, markets, carbon, and energy. So if we start with construction, we know if we go through the process of constructing a building, we begin with the conceptual design stage, move into design development, project execution, controls, and then ultimately closeout. What we know from early on in the construction process is material knowledge and availability of materials is a key decision during conceptualization, as well as more and more concerns about sustainability and how a building can be delivered in a sustainable fashion. Similarly, when we get into later design stages in the execution stage, we worry about costs and project duration. And then as we get into later stages of the project, we worry more about customer satisfaction and final costs and project duration. And so the question is, what does all of this have to do with mass timber? And these are really cost and benefit related issues and concerns throughout the life cycle of a project. And if we begin early in this conceptualization phase, sorry about that, let's go back to later phases of the project when we get to closeout. Using some projects that have been executed in the Midwest as an example, if we take a standard $100 million, whether it's steel, concrete, or mass timber project, we know that indirect costs will range somewhere in the $2 to $5 million range, and then time-dependent indirect costs will range from $1.5 to $4 million. If we look at schedule savings that are possible based on learning curve for new firms that are getting into mass timber or experienced mass timber firms that are perhaps executing their third, fourth, or fifth mass timber project, we see that schedule reductions of about 23% are possible, which just on general conditions and indirect costs can lead to anywhere from $350,000 to $900,000 in indirect cost savings on a $100 million project. So the question becomes, if we can save this kind of money just on indirects using mass timber, why aren't we doing more mass timber projects? And what we find out from studies that have been done within the last 5 years are that really lack of familiarity and concern about construction costing is a key issue that's keeping architects, engineers, and general contractors away from this material. And this causes a cycle of lack of recognition of the material, cost ambiguity, and it sort of keeps the material out of common use in our industry. So we undertook a project at MSU to look at development of a predictive cost model for mass timber structures as a way to help during that early stage of the construction project's life cycle, during conceptualization and early design phase, to make some of these decisions really with more information in hand to decide if mass timber is a viable alternative. But there are some challenges to developing a model like this. We don't have a lot of mass timber buildings in the United States to draw our inferences from. Different projects are, of course, very variable and unique from one another, so there's great variability in a small data set. The information that we received in some cases in building this model comes from early project stages versus some later project stage information that we would prefer to have. And data availability is a challenge in terms of pre-construction data versus closeout data. So we have a mismatch in the kind of data that's available to us, which leads to some challenges with data quality. Nonetheless, we assembled a database of projects from around the country. You can see the states where the projects were gathered from. And again, many of these were gathered from pre-construction phase data. And then we worked through a number of variables that relate to each of those buildings, and I'm not going to name them off, but you can see them on the left-hand side. We then looked through those variables to see if any of these variables are outliers, things that are so out of the norm, even with a small sample size of about 28 buildings, that they might cause trouble for developing a predictive cost model. We then used that project data. We ran some regressions. Lucky for everybody on the call today, I'm not doing talk about statistics. This is just the output of the statistical models. The one on the left has many more variables in it. You can see the variables at the bottom: area, total material quantity, labor cost, material cost, general conditions, worker hours, equipment hours. But these are often data points that are not known at the earliest stages of the project. So the model on the right only uses 3 variables: stories of wood, gross floor area, and total material quantity for mass timber. Variables that would be well known during early stages of the project. And you'll see, if you remember our square values, even with those 3 variables, we're able to develop a model that predicts about 95% of the system cost just with those 3 variables. So we then test drove the tool. We developed a public-facing, it's just an Excel spreadsheet that anybody can access and use as they wish. Put your data in with values for those 3 variables. And we tested with one case study. You can see from kind of that Mountain West region of the US, actual system cost was $10 million. We predicted 9.147 million for the mass timber system. So the model undershot that building by 8.7%. Again, if you're using this during conceptualization phase and early design phase, something that's plus or minus 10% at that stage of the game is not uncommon. We then looked at a second case study that was located in the Midwest. Total CLT system cost was 5.98 million, and the model predicted 5.864 million. So the model, in this case, actually undershot by less than 2%. So limitations to the model, of course, again, small sample size. We were limited in scope. We really reduced a lot of that variability by only looking at the CLT frame elements, so the gravity frame. And the current model is not sensitive to price changes for the commodity, which is a challenge right now, because if you're watching the news and watching markets on lumber, you know that random length framing lumber composite prices are basically at their highest that they've ever been, closing in on $1,000 per 1,000 board feet, so $1 per board foot. and you can see over time what that pricing has looked like. So one of the challenges with a commodity priced object is what happens when, because of tariffs, because of supply-demand imbalance like we're seeing now, what happens when those prices get higher. So our research group is also looking at using salvaged lumber from urban sources, mostly deconstructed lumber, and evaluating its suitability for use in mass timber. You can see from the performance graph at the bottom, about 84% of our samples test out adequately for use in CLT manufacture. So we've got a pretty significant resource base available to us that's unused, that's untapped right now, that might be considered for these products. We've estimated that the current stumpage price, if you will, for this salvaged material is about $833 per 1,000 board feet. So when the Great Lakes average is usually hovering around $450 per 1,000, that $833 per 1,000 number is high. As prices go up, of course, we gain some opportunity in that space, but we also have to look at other values for that material, and we can start by looking at carbon savings, and we can look at how much carbon is in the lumber in a single family detached house, average house in Michigan, which is about 8.6 tons of lumber. And if we start breaking down some different options versus landfilling all of that material, do some source reduction, do some recycling into mass timber, do some landfilling and some combustion, which are pretty common disposal options that we're seeking to minimize by putting more of this product into mass timber, we find that we can save about 6.4 metric tons of carbon dioxide equivalent by using some kind of mix like I'm showing you in those bullets up above, which if we look back at the old Chicago Climate Exchange, the last effort in the Midwest to trade carbon credits, you don't get much monetary value even at their peak CCX trading at $7.50 per metric ton out of a single house. But if you take a number of those homes and develop the lumber to build a STEM building at MSU based on carbon sequestration values that we've calculated for that building, now you're talking about almost $14,000 of potential carbon credits that are available, would be available at those peak CCX credit trading prices just in the STEM building. And then to finish up, we've also looked, this is for a confidential project that we worked on, just doing some energy modeling of a mass timber and concrete deck option versus a steel frame and concrete deck option. Bottom line story is this. Mass timber consumes about 5.5% less energy per year because of the R value difference in the wall sections that we see in that mass timber building versus the conventional steel and concrete building. So now if we can start to think about where our costs and our benefits come from during construction, and now there's potential cost savings that might pass to the owner and operator of the building. Now we have to start thinking a little bit differently about what the value proposition of mass timber is, especially when coupling it with things that you heard about last week from Kelly Millenbaugh about educational environments and creating better educational spaces. And John LeFevre, who's going to present after me, I believe, is going to speak more to some of those market and non-market values that need to be considered. Quick acknowledgements. A lot of our work has been funded by the Forest Service. A lot of the cost-benefit model work was done by my former graduate student, Bhushan Nankar, who now works for Swinnerton Mass Timber out in Portland, Oregon. And then Dr. Mojgan Najad from MSU Department of Forestry and Dr. Matt Sayal from my department also contributed to the modeling paper. So I think we'll be taking questions at the end of the session, but thank you for your time, and I'll look forward to answering those questions a little bit later.
Thank you very much, George. You were spot on for time. I can honestly say that's a great way to start off our second day of sessions with the Michigan Mass Timber Summit. Well, George, if you want to go ahead and close out your microphone and your screen and shut your webcam off, then we're going to bring on Dr. Mark Rudnicki from Michigan Tech University, and he's going to go ahead and get himself going. Keep in mind, everyone, we will be taking questions at the end of this particular block of sessions, That question and answer will start at approximately 9:30. Good morning, Mark. We can see you and we can see your presentation. So I'm going to go ahead and shut myself off and turn it over to you, sir. You're ready to go.
Okay, thanks. Yep, I just need to, it looks like it's showing the wrong screen. I need to show my other screen. So if I can fix that. Oh, there it is. There we go. Thanks, Brenda. Yeah, so this morning I'm going to be talking about the HSTEM building, the Health Engineering, Health and Technologies Complex that is planned for Michigan Tech University, and talk about the work that we've been doing to try to get that building to be mass timber. So a little bit about the background of the HSTEM complex. This is Michigan Tech's integrated educational programs and health-related human-centered technological innovations. This is really a building that is focused, is primarily focused on research and health technologies. And it's meant to be a big collaborative space for engineers, health technology folks, all the people, all the different departments participating in this kind of work. There's been a very big direction shift for Michigan Tech and a big investment in this area. So the project, well, the project really started, probably started being envisioned way back in, I don't know, 2014, 15, but a big milestone was that in 2018, the Michigan legislature granted planning authorization for the building. And so at that point, there was serious investment by Michigan Tech to start planning the building. So the building consists of a $29.7 million request from the state of Michigan, and with a $15 million match from Michigan Tech. So a total cost budgeted $44.7 million, and the total square foot of the building is 135 square feet. So some renderings of the building, I can share those with you. This building is intended to be pretty much right in the middle of campus. If you're familiar with Michigan Tech's campus, we have the library here, the student union, and it's going to be built right along the side. The plan is right alongside of the Chem Science building. So it'll be basically integrated into the side of that existing building. So here's some renderings, what that is hoped to look like. So you can see the Chem Sci building is taller in the background, and this, you might even call it a new wing of that building, although it'll have a very different purpose than just Chem Sci. Here's a view from the top. There's been discussion about a possible green roof on the building, and a view from the rear would be all glass and looking out towards the canal. So a little bit of the inside of the building, and to give you a better sense of the purpose intended, I'm just going to show you one floor. The green area down on the bottom is intended to be all faculty offices, research offices. Then you transition to grad student offices, and then all the purple is all research space. Configurable, really large rooms that with a lot of open space that's reconfigurable, and that's important when we go down the line here and talk about the design restraints and constrictions. And then you can see at the very top of the screen, you can see the existing chemistry building, and that's also going to include some remodeling to interface with this new building and remodel some of those labs as well. So the other two floors kind of are the same, so I'm not going to go through every floor. Just to give you a sense of, there's a lot of research space dedicated for this building. Just briefly go over this timeline. So we got the authorization for planning in late 2018, and then we brought together lots of departments for visioning in the spring of 2019. Design team selection, again, late spring, early summer 19. And this was all going on time, smoothly, and project kickoff July 2019. And then the programming, August, September, conceptual design phase went well, and then we ran into the schematic design, and of course, we ran into COVID. And so since then, everything's been put on hold. And so, but I'll talk, we've had some very recent information about the building that I'll share at the end where it stands, but I'll go through the rest of this before that. So, and talk about some more details. The design team selection. So the design team was Harley Ellis Devereaux, and they're Michigan, Chicago based, Detroit, Chicago based. And although they did not have any mass timber experience, and right up front, that was expressed in the RFQ issued by Michigan Tech that we wanted someone with mass timber experience, because that was already from the very beginning that was expressed as a desire to see that building in mass timber. And so HED subcontracted Arup to help them with all the mass timber aspects of this. And Arup, and I was really happy to see that, because Arup is a global company and has been involved in mass timber for since it really started in North America and overseas as well. And they've been also leading the promotion of mass timber with, for instance, this particular publication, Rethinking Timber Buildings. So I was happy that we had a good team together. And also the promotion or the examination of how we can make this building mass timber was reinforced with a grant that I won from the U.S. Endowment for Forests and Communities and the Forest Service. And then after some initial design, Grainger was selected as the builder. And I think that, I suspect that had a lot to do with their recent experience with Michigan State mass timber and being, again, an in-state contractor. So one of the products, or one of the things that come out of the grant was a case study. And that's, while the case study itself is still in development, we contracted or stressed to HED and Grainger the need for them to issue a feasibility report for mass timber to investigate how using mass timber in this building would, how feasible it would be, what's the costs. And so the report looks at all the possible structural systems, structural design criteria, structural systems, a fire review, preliminary code review, and construction fire safety. Some of the, and I hinted on this a little bit, some of the important design criteria that I think were offered some challenge for mass timber was that we did have some long spans needed for these research labs. And also these research labs are very vibration sensitive. And so that means you have to really thicken up whatever structure you're using to keep things very stable. And of course, the research equipment, we wanted those rooms to be reconfigurable so that down the road, if the building is decided to be used for a different purpose, we wouldn't be constrained by small rooms or dedicated rooms. And so many of these criteria called for significant amounts of 5- and 7-layer CLT. And when you get into 7-layer CLT, your costs really start to go up. Another table that was issued in that report was comparing the different structural systems, the steel concrete composite, concrete slab on beams, and just gave them a rating system of how favorable they would be, and compared that to timber CLT and a timber CLT plus concrete composite. So if we just look at the timber CLT, it came out very good, yes, very positive in all of these categories. And so it was a sort of reality check to make sure that CLT and mass timber was going to be a good option for this building. So it certainly passed that with flying colors, I would say. So now the real big issue, and that's the actual cost for this building to do it in mass timber. So we sent the designs, the estimates for this, the designs to a few different mass timber vendors across the country. Initially, it was just sent to Nordic, and Granger came up with their own number on what the mass timber materials would cost. And so we saw a big difference between estimates of different companies. So we started with Nordic, and then we said, well, the grant really required getting at least 3 different vendors to put an estimate in. So we went back and actually included 4 different vendors. And you can see quite a bit of difference in dollar per square foot on that. And of course, these numbers are from back in February. So these numbers may have all changed, and I expect they will. But still going with those numbers, so those same numbers given in millions of dollars. And then the big question was, well, how does that compare to steel and concrete? And the steel estimates came in significantly lower to build that same building, or rather achieve those same design criteria with steel. So we were looking at about a $1.6 to $1.8 million premium to go with mass timber. Depending on what vendor you chose, you might go a little bit less. And that ends up being about a 40% higher building frame structure cost. And that's quite a bit. But for the total building cost, it's only 3.6% higher. So it depends, I guess, which number you want to look at, but it's still the number most people are looking at that are paying for this is this going to fit our budget? And 1.6 extra is a big challenge. And so we went back and said, okay, well, that's a big problem. So we went back to the design team and said, what can we do? How can we adjust the design? Is there something we missed? And we called Woodworks, and we asked Archie and his folks to look at this, and it was very challenging with the design criteria we had. There was some headway, but nothing. We couldn't come up with anything that would really, go up to even over $1 million for cost savings. So the discussions became, well, we could do a hybrid structure. We could do partly mass timber, partly steel. So we're still talking about how much wood we could use, or is there some way for someone to pitch in that extra cost? And this is, it's disappointing, but not terribly surprising, I would say. The material is not cheap. Cross-laminated timber is not cheap itself. And I want to stress here, this is installed. This includes the labor. This is not just the material. This is the installed enclosed frame. So that's a very important point. So even though there's a lot of discussion how there's and a lot of evidence that shows that there's a lot of time savings and you get a lot of cost savings there. Sometimes the numbers don't add up, and it really depends on, you know, the companies that are pulling this together and what their cost estimates are. So in our example, this is the these are the results for our building. So a little bit of I'd say speculation on why this is, or a reflection. Mass timber prices we saw varied a lot between vendor, and we're seeing that changing a lot over time. So that's a little worrisome there, that the cost for wood is now going to be much higher. And it also, we saw a big difference between the more established companies like Nordic and Structural Lam and the newer companies like Vaughan and oh, that other one out in British Columbia. That they were a little more hungry and they were charging a little bit less, but I don't know where that's going to be now with CLT in big demand across North America. But Michigan still, and probably even more so for Michigan Tech, we're far from those CLT producers. Those shipping costs are going to be an issue. But you know, I also want to stress this is early days for mass timber in Michigan. I think this reflects, you know, labor and time costs are still a premium. This, I think, is still seen as a risky endeavor. We're going to see a little bit more. Okay, I see Brenda, so I'm gonna skip to my last slide here pretty soon here. Let's see. Yeah, so I'm hopeful that we're gonna see mass timber at Michigan Tech. We saw a lot of the benefits. People are talking a lot about the long-term benefits, you know, the cost savings down the road. Unfortunately, you know, when you have a budget, it's really difficult, if not impossible, to take those things into consideration. The budget is what you have to spend. And then finally, I'm going to skip to my last slide. Where does it stand now? Just last week, well, we did get our draft phase 2 300 progress report to the DTMB. That, like I mentioned, that was put on hold, but just last week, that DTMB informed us that they completed that review and they'll be meeting with Michigan Tech in the next few weeks. Then this goes to the legislature for funding approval, so there is still opportunity for additional funding to cover that premium. And I would like to also thank our funders and support. Thanks.
Thank you, Mark. You did great on time. Sorry we had to push you up the scale a little bit there, but great content. We really appreciate you joining us. If you want to go ahead and turn off your camera, and we will then transition over to John LeFevre. When you're ready, John, you can go ahead and turn your camera on, and we will get you up on the screen as we get moving along. So Mark, we do need you to, there we go, excellent, thank you. And John, if you're ready, I'm gonna go ahead and turn my camera off. We can see your slides. Excellent, thank you, sir.
Okay, good morning, everybody. Is my volume okay?
You sound great.
Okay, thanks. Again, my name's John LeFevre, Director of Planning, Design, and Construction at Michigan State. I'll be really, a lot of you are already familiar with the STEM project here at MSU, and my presentation is going to focus more on success factors and how we sold and brought into the project the ability to deliver a mass timber project and some of the call it softer side of the project outside of strong benefit cost ratios on how we made this project reality. I'm going to outline the buy-in at the project pre-planning phase, the importance of education and communication about mass timber, integrating the stakeholder decision team, and then understanding all aspects of the cost benefit criteria and their interdependencies. First of all, when we talk about buy-in, we're very fortunate here at Michigan State in that our administration very much was encouraging and supporting innovation in construction. We've had really a very, I'd call it robust institutional construction standards in place for many decades here. And really our construction methods up until this project to a large degree were very institutional and conventional. They focused on delivering the best life cycle cost and 50-year plus life. But we were challenged, as were our design and construction professionals, to look at innovation and look at options for this project. And I want to talk some about how getting that whole team together, that buy-in was important. In addition to the MSU administration encouragement of looking at innovation, we have on campus the Department of Forestry, Rich Kobe's team, who have been very much involved with mass timber CLT research and innovation, and having that resource on campus and that encouragement to consider that as an option for our project was very critical. We also have the School of Planning, Design, and Construction. We heard from George earlier in the presentation, where they're teaching efficiencies, project management, design options, and choosing by advantages through their program in the School of Planning, Design, and Construction. And so having all of those resources available to the team before going out for RFP and before going into the design phase is really critical. I think I can say without hesitation that any of those team members that were involved with this project who are really passionate about mass timber would offer help, assistance, direction going forward with your project or people who might be on the call considering this. And I think it's also very important to point out, as Michigan Tech and Mark outlined, is this isn't necessarily going to be a lowest cost option. If pure economics is going to drive the decision-making process, this option is not going to win out. You have to have, call it the buy-in and the additional factors accepted by the team and the decision-making group to be able to get this option to proceed. So I go next to the education and communication outreach for mass timber. I think it's very important that seeing is believing. I think probably most of the people participating in this webinar have either direct interest or direct experience with a mass timber project and want to see that be successful. It was very important for our design team and construction team to view other projects. One in Boston that half a dozen people went out to see. After that site visit, there became even more excitement about the possibility of making the mass timber selection for our project here at Michigan State. The architectural improvements associated with mass timber that are really hard to describe until you're in the space of a mass timber project. We look at what students want, what the educational experience is going to be inside the space, and those all become additional factors in helping promote that option for us. The choosing by advantages methodology was also very important. When all the other intrinsic factors of what the space feels like, the acoustical properties, what can be saved in terms of labor on site, how soon you can get the building trades, other building trades working in the space, all of those become very important factors in the cost-benefit analysis. And it's not just, as Mark pointed out, call it the 40% premium of costs. You have to factor in all of the other aspects of the project costs to be able to look at the whole picture. Team integration. As I mentioned, the team visits to the site. We also went to 2 different manufacturers in Canada to look at the manufacturing operation, and bringing that knowledge back and expanding it to the other decision makers within our team in administration was very important to help sell this concept. Again, the cost alone is not going to drive it. The team has to be sold on all of the other benefits of mass timber to be able to see the whole picture. Material costs are going to be more important or more expensive, but the labor savings and getting the trades in quicker is going to save money and help balance that premium that you pay for the material costs. Another important factor is the choosing by advantages process. Is there has to be a relatively early decision made in schematic design that you're going to go with mass timber, because you can't continue to design the project and develop cost models with 2 or 3 framing scenarios forever. It's very important that that decision gets made somewhere in the conceptual design phase, so that more detail and more cost modeling can be done, and that choosing by advantages methodology in the conceptual design phase is very important. Of course, realize our limited sample size of projects to rely on. We've been building steel and concrete frame projects for decades. As I mentioned earlier, our institutional construction philosophy here, we have decades of experience with those cost models. And so the difference between a conceptual design and where the cost model for that may end up and what it ultimately develops in final design are likely to be closer together. Given we've got limited manufacturers and limited experience, the design team and the decision-making team has to understand that evolution of the cost model and through the process there should be an expectation that delta or that difference between conceptual estimating and final estimating is going to have a bigger difference than what you would see in a steel frame or a concrete frame building. The ultimate process of having everybody on board in that education and communication section is so important that the team can see those additional benefits and justify the expense or the difference because of all those intangible pluses that come with this methodology. So at this point, I'd like to go to questions and answers. I want to thank everybody on our design team that put their passion into this project, made it possible to sell to the state and to the administration, and we will help anybody on the call any way we can to help your project be successful going forward and overcome some of these cost-benefit barriers that may be perceived.
Thank you very much, John. We appreciate you joining us. So what we'll have you do is you're going to stop sharing your screen. I think the controls are gonna make that happen internally, possibly. And what we're going to do now, folks, is we have plenty of time for a good question and answer session. I'd like all three of our speakers to come back on screen: George Berghorn, Mark Rudnicki, John LeFevre. And since John just finished up talking, we're actually going to start off with George, and we're going to do a little bit of round robin. I've got questions for each one of you, and I'm going to pull those up off of my Word document. So I'm actually going to shut my camera off for right now. You'll hear me speak, but I am going to allow you to answer the questions. So I'm going to target them at each of you. If we have any last-minute questions come in, we'll feed those over. So John, when you get a minute, we do need you to turn your camera back on, please. So there we go, thank you. All right, the first question for George. You mentioned that the quote-unquote stumpage price of salvaged lumber for use in CLT fabrication was about $833 per MBF. Roughly how much more than average is that than the average southern yellow pine construction lumber?
Yeah, so I think I compared to Great Lakes region random lengths at like 450 per thousand. Southern yellow pine is considerably lower than that. I mean, everything's trading high right now, but if you go back and look at trend charts from actual prices and future price forecasts going back a year, you're somewhere in the threes, the low to mid threes for southern yellow pine. So it's considerable. It's considerably more expensive right now, which is why I think it's important that we start looking at other values that may be intrinsic to that product, which is why I brought in the carbon issue. If we do ever get to a point where we're looking at cap and trade or some kind of carbon credit trading scheme again, but it also doesn't include the fact that we're also working on economic value for the material that's not structurally reusable. So that 833 per thousand has to absorb a large fraction of salvage material that's not structurally reusable, about 50%, because of rot, insect damage, et cetera. So there's some work ongoing at MSU to make resins, lignin-based resins. So now the question is, can we transition from commercially available lignin to lignin that's sourced from salvage material? Can we look at non-structural applications for the material like highway sound walls and things like that? So it's a great question, and it's definitely an issue that has to be worked on if we're going to see more of that material make it viably into the market.
Brenda?
Yeah, I'm going to have to start doing my Irish soft shoe, and nobody wants to see that. So.
Sorry about that, folks. I was muted. That was my fault. I try to make sure we don't have any backfeed if I'm using my keyboard. So question for Mark. How much did the requirement for 5 to 7 layer CLT floors affect the bid price did you receive any feedback on that from manufacturers?
Well, I mean, they okay, whoever clicked something, that was good. They did, break that down in their estimates for us. And so, that I think that was, that's going to vary by vendor, but I think it was maybe 20% for the 7-layer, 20% for the 5. I'd have to look at those numbers. But it was pretty significant. Yeah, it might have been half the price for 5 and 7-layer, something in that range.
Okay, thank you. I made sure I took myself off of mute this time. So next question up for John. John, you mentioned how important that education and communication piece is. I was wondering if, and this is actually my question, I was wondering if there is work being done on that education and communication point as it relates to our students that are there at the university. We do know that sometimes the media message about the use of wood products is less than favorable at times. Is there a plan for how to really disseminate and educate and inform the student body as that structure continues? John's trying to unmute and we don't have you unmuted yet, John. Nope. John, hold on. We've got to unmute you.
Actually, on the education piece with the students, I'm going to call on George as far as what's being done there. I can tell you we have been, I can't tell you how many tours we've done of this site as outreach to both students and user groups from all over. That aspect, as I mentioned in the presentation, the feel of the space when you're in it is really a huge selling point. But how that is introduced and getting into more detail with the curriculum in particular, George, you can help with responding to that if you would.
Sure. We've started to work mass timber content, at least in the construction management program, into several of our courses. There's now a unit on mass timber in our commercial materials and methods course. I work some of the schedule dynamics that John was referring to in his presentation into our graduate scheduling course. We work mass timber into a circular economy deconstruction course, into a green buildings course, actually 2 green buildings courses. Forestry and construction management now have a joint wood composite construction course, which really talks about soup to nuts, many of these components. And we're in the process of working with a national level funder to develop what a mass timber curriculum that's inside of existing construction management programs might look like for the future as well.
Thank you very much. All right, since George just spoke, Mark, I'll jump over to you. Question is, did the specified design include other measures for dampening vibration or just a complete wood design versus concrete and steel design?
Yeah, in the initial, we just went with that complete wood design and what would that cost, right? And then, but as far as I know, there has not been any in-depth investigation into what a hybrid design, how might that go or how might that perform. And I also want to stress, we've got very good buy-in across Michigan Tech for this kind of building. And now, we've got to face this reality of this premium and where are we going to come up with those funds? And also, those educational benefits, those are many of those things, we see those as well, and really look forward to being able to deliver on those. And one last comment I want to make was that, you know, this is part of, again, I mentioned this is early days for mass timber in Michigan, and we need more of these buildings to start, you know, establishing the supply chains, getting construction companies used to this, getting the labor force trained, get everyone to understand what are the costs, and so they're more comfortable and they realize it's not as risky as they might think, and much of those labor costs and other costs should start coming down as well. And the COVID-related lumber prices, I'm hoping that's just a blip, and that'll smooth out as well. So I don't think that's a permanent elevation in timber costs.
Great point. Yes, Mark, I do believe we're all hoping those construction costs on lumber start to even out and come down a bit. Question for John. John, can you describe the choosing by advantages process again, please?
Sure. The choosing by advantages, I guess the team that led that is a combination of our architect, IDS, Integrated Design Solutions, and Granger Construction. But it goes through, we could probably do a whole session on that with, and I would be glad to put in my slide deck when we conclude. There's a couple of pages of the chart of choosing by advantages, looking at contrasting the wood and the steel frame, and both what the cost and the benefits for each of those are, and include that with my slides when we conclude, and that would probably help demonstrate showing that matrix. I don't have it handy to pull up this second, but I can include that with the remarks today.
Thank you, John. All right, next up, question again for George. What kinds of trends did your research team see in case studies for mass timber projects? Did they cost more or less than the planners expected in execution?
So for, excuse me, for the limited number of projects that we had pre-construction and closeout data for, they show cost increase. You know, I think John alluded to this too. You know, if you look at the difference between a conceptual estimate and then the final number that a project is brought in at, there's always inevitably some increase in those numbers. The scale of that increase wasn't really in the scope of what we were doing. We would have to go back and look at that to see how that tracks with what you might expect in an increase for steel or a reinforced concrete building, but there's definitely some increase.
Very good, thank you. Next question for Mark. Did the cost estimates for mass timber depend on use of wood sourced from Michigan?
No, I think that would add quite a bit more if you had to source wood from Michigan and ship it out to a CLT manufacturer and then ship it back. It could be done, but that would be even more cost.
Thank you. George, you noted that mass timber uses 5% less energy per year for the heating and cooling. What about in cold climates? Would that be even less, since you wouldn't have to warm up concrete when it's, let's say, minus 20 degrees Fahrenheit in the UP?
That 5.5% savings that we noted, that building was actually in a cold climate. It was climate zone 5, so certainly not the coldest, but edging into cold climate. We would expect higher savings in colder climates because one of the biggest issues that we noted in the energy model was the reduction in vertical transmission of heat loss because of the use of wood structural members instead of steel, and the wood CLT floor plates in that construction method. So in essence, the R value of 1 per inch that you get out of wood, which we don't normally think of as being an advantage in a light frame construction scenario. Because of the use of a 5-ply floor plate, you've got a significant amount of insulation value in that material, so your thermal losses floor to floor are actually greatly reduced. So in a colder climate where there's more thermal drive that's trying to push, move thermal energy more quickly through that building, we would expect you would see something greater than even that 5.5% savings in that same building. I do need to caution, that's a one-off, right? That's a model of one building under one set of construction and design restrictions. But yeah, I think if you move the climate to even colder, you would see a greater savings.
Excellent, thank you. Last question, I do believe, and then we will open it up for any last comments that we need to. Mark, you noted as we went through the HSTEM building, different features of the exterior. If there was an interior picture, I didn't notice it, so I will ask this question. We hear lots of things about the benefits of seeing wood, especially in healthcare type settings, and its soothing effects, its calming effects. Do you know, will the interior of the proposed HSTEM building be able to see a high percentage of exposed wood so that the people that are using it could potentially see the benefits from that?
Strictly speaking, I can't answer that. The renderings were all just in black and white. So, but I do believe the plan, there was not a plan, since it's only 3 stories. I don't think we need to cover everything with drywall. I think there was going to be exposed wood. And so, yes, the people working in those buildings, I think, would receive those benefits. I think that was the plan, or I think that is the idea there. Yep.
Excellent. Okay, I have another question just came in, and we'll figure out who's going to answer this, I guess. We'll start off with the question, since it just popped through. How are the premiums different than other green building strategies, especially with structural design? Maybe we'll just start off with George on that one. So the question was, again, how are the premiums different than other green building strategies, especially structural design?
Okay, so if we look at Mark's building, you said about 1.5 million was your structural premium, Mark, is that right?
Yeah, 1.6, 1.8. Yeah,
okay,
give it.
Sure.
Yeah.
I mean, hey, round numbers. We're all
right.
We're all among friends here. What was your total project cost again?
44.7. So it was only about 3.5% of the total building.
So, I mean, then you're right in where, currently we see LEED Gold and LEED Platinum buildings coming in overall, with a premium of somewhere around 2 to 3% for gold and significantly higher for platinum. So if you're only isolating that structural element, yeah, you're right in line with that. However, that premium for LEED, of course, takes into consideration a lot more items than just the material. So if these buildings then do try to approach LEED, I think you'll see some growth from there. But I do just want to say on that point, one thing, I think as constructors, particularly general contractors, become more familiar with this material and more familiar with the method, I think you're going to start to see more contractors factor in the fact that they can save some of their general conditions costs by executing a project more quickly. I don't think we're seeing that, at least in our markets, so basically anything other than the Pacific Northwest markets right now, just because of lack of experience. So I think you'll start to see that premium come down as GCs better understand their general condition savings and they can bid appropriately.
And if I could, Brenda, the previous question on the energy, we will have, within a year or so, some in situ data. Certainly the model would demonstrate that our energy efficiency for this mass timber building should perform better. With our central control data and being able to compare and benchmark with other science buildings that were recently constructed on campus. Within a year or two, we'll have some very good actual data to benchmark and share.
Excellent. Thank you both. Go ahead,
I would
Mark.
just add very briefly that to George's point, and I would just, as GCs get more experience, costs should come down. And basically, I would again repeat, that's why we need more of these buildings in the state. It's another discussion to talk about manufacturing in the state and how that might affect costs, right? And that should have a positive influence. But that's another, since that's not imminent, that's another discussion, I think.
Absolutely. That is one of our true key drivers of outcomes that we'd like to see, is attract CLT manufacturer to the state of Michigan. So that all of that led into the question that came into the chat, which is, how long will it take for operational expenses to overcome the initial premium? And you all touched on that possibly just a little bit, but if George, you're nodding, so go ahead.
Yeah, I mean, I can just tell you from the energy model that we ran for that cold climate building, based on the size of the building, the energy rates that were in place at the time, you were looking at a 10-year savings of $500,000 in utility costs alone. So, we don't know what the cost premium was on that building. That wasn't part of what we were working on. It was strictly the energy piece. But yeah, I think those are not insignificant amounts of savings, again, particularly as our knowledge base expands and our price per square foot starts to come down.
Excellent.
Well, that's a question. I want to crunch the numbers for our building, because I'd really like to present that to decision makers. Those other benefits, not just energy, but any other kind of cost that we could add and help build that case.
Excellent. Question just came in to the chat for Mark. Mark, you mentioned long spans were specified in the design, and that might have affected the cost. Can you share what the grid spacing was and the span was? Do you know?
I was afraid of this question. The actual numbers, I can, my presentation actually has has a scale in there, but I don't have that number.
That's okay.
Yeah.
If you want to share it with us at any point, if you find it, you can feel free to share it, and then we can always disseminate it out, but no worries there. Okay, gentlemen, any final parting words? It looks like we have finished out the questions. Okay, well, we'll have
my parting word.
Thank you very much to all three of you for participating. We really enjoyed having you with us. If you want to go ahead and shut your cameras off and turn your mics off, and then we will send everyone to break.
Thank you, Brenda.
You're welcome, John. Okay, getting everybody closed out. So to those of you that are here with us, it looks like we have 108 attendees at this point. We welcome all of you. Thank you so much